Hello guys, my name is Shiv Patel. I am from third year of electronics and DJ Sangvi College of Engineering. In this experiment, I am going to show how to implement linear equation using opamp and working of adder and subtractor, and finally simulate them using simulation tool LT Spice. So let's open the LT Spice software. For linear equation, our linear equation is 2VA plus 3VB minus 4VC. So we will need two op-amps. I'm going to use OP07 in this case. For that, go to component, type OP07, press enter and place it wherever required. After that, we will require resistors. So for resistor, go to resistor. Then to rotate those resistors, press Ctrl R and place it wherever required. Now we will connect them using wires. For that, click on wire and connect them. Now we will have to apply ground to the non-inverting terminal of the op-amp. So let's apply ground. For that, click on wire, then ground it using ground component to both the op-amps. We also need voltage sources to inverting input terminal. So go to component, type voltage, press enter, connect them over here. The negative terminal of the voltage sources should be grounded. So let's ground them. Let's apply voltages of 1 volt to each voltage sources. Now let's apply VCC and VEE. For that, go to component, voltage, press OK. Place it over here, connect them using wires. Round the common terminal using round component. Right click over here to label. Click on label net. Type VCC. Place it over here and wherever required. Edit them to VEE. We have to apply 15 volts to both of them. For that, type 15 volt and 15 volt. So now let's assume 10k feedback resistance. So type 10k, 10k. So the RA resistor will be 10k upon 2 because our equation has 2VA. So 10k upon 2 is 5k, but 5k standard resistance is not available. So that's why I'm going to use 3.9k, 1k and 100 ohms. This is equivalent to 5k. I have connected them in series, and this resistor will be 10 upon 3, which is 3.3. Because of the linear equation used, this will be 10 upon 4, which is equal to 2.5, and because of standard resistance I will use 1.5k and 1k, and this will be 10k. So let's label this as output terminal. For that, right click, label net. Our output will be 2 into 1, 3 into 1 4 into 1, which is equivalent to 5 minus 4 is equal to 1 volt. The output should be 1 volt. So let's run this. Right click, click on run. DC output. Okay. Close this window. Click over here. So the output is 1.030 volt, which is almost equivalent to 1 volt. So theoretical and simulated output is almost same. Now let's move to the non-inverting adder. I already designed the circuit. In non-inverting adder, we are using 3 input voltage supplies and 3 input resistor having resistance 10k each. The feedback resistor is also 10k and this is 5k equivalent. Now to run this, right click over here, click on run. Our theoretical output should be addition of these 3, which is equal to 4 plus 3 plus 2, which is equivalent to 9 volt. So let's see the simulated output. Close this window, click over here. Our simulated output is almost 9 volt as theoretical. So they both are almost equivalent. So now let's move to the subtractor. The subtractor is V out is equal to VA minus VB, and we are going to use two input voltage supplies of 2 volt and 3 volt in this case, and resistor will be 10k. The feedback resistor will also be 10k. So the output should be 3 minus 2, which is equivalent to 1 volt. So let's see whether the simulation goes perfectly. It's this question mark symbol over here. This is 999.99 millivolt, which is almost equivalent to 1 volt. So theoretical and simulated output is almost same. Now let's move to the linear equation using opamp. Uh, the linear equation is V out is equal to 2VA plus 3VB minus 4VC. For different values of VA, VB and VC, we will get different outputs. Let's take a case of 5 volt, 1 volt and 2 volt. So theoretical output will be on substituting these values into this equation is 5 volt. Let's see the simulated output. The simulated output is almost equivalent to 5 volt. We got 5.030, which is almost equivalent to 5 volt. Let's go to non-inverting adder. Let's take a case of 1 volt, 3 volt and 1 volt. Addition of these three will be 5 volt. So let's see the simulated output. The simulated output is 4.999 volt, which is almost equivalent to 5 volt. Let's go to subtractor. Let's take a case of 5 volt and 1 volt. So subtraction of these two will be 4 volt. Let's see. Yes, we got 3.999 volt, which is almost equivalent to 4 volt. So I I have already explained the implementation of linear equation and working of adder and subtractor using LT-Spice. So that's all for this video and thank you.